Hello class, here and welcome to this particular video. And in here we're going to be looking at parallel versus perpendicular lines, and these will be connected rightly to equations of lines and graphs. So the goal of this particular video here is to first know or should be able to determine the slope of any line, and from there you'll be able to prove that two or more lines are perpendicular or parallel. And those two terms, you need to actually recognize them not only mathematically but in your daily lives, either on a real track or on your skateboard, or if you have pencil with the lines to write on and you have a plug in there. And all these are actually applicable not only mathematically but in the workplace. And finally here you'll be able to look at the applications to various problems. So looking at this particular big idea question, which says that for the given vertices, determine whether or not this triangle ABC is a right triangle. So there are a couple of key terms here. What are vertices? And vertices, we notice, are points. In this case we have this point A, we have point B, and we have point C, and all those points, once you connect them, you should be able to form a triangle, which in this case is represented as triangle ABC. And we want to know whether this triangle here is a right triangle, and that is a big question. What is a right triangle? What makes a triangle to be a right angled triangle? So before we actually dive into this particular question, we're going to look at or explore two lines with their equations. And in here we see two graphs, and these two graphs each has two lines, and the line here is green and blue. And we see some interesting differences here between the two graphs. Now, looking at graph A, we actually see that first we have line 1, which is green. Line 1 has an equation which is represented as that. And for line 2, we have an equation that is also represented as that. And what we see is that there is a commonality between line 1 and line 2. In this case, we see that this is actually related to the slope, and the slope here are the same, connecting line 1 and line 2. So once we notice or recognize that the slopes are actually the same, we have to conclude that indeed these particular lines are actually parallel to each other. It could be parallel and coincident or parallel and distinct, but we don't really care about that for now. What we do care about here is that the slope, you have to recognize that to be the same, for those two lines to be parallel to each other. So this is the key note to remember here. And for graph B, what we see is that the two lines, they actually meet at a point. And if you look closely at line 1 and line 2, the point where they meet, if you place a specific protractor in here on it, you should recognize that the angle made between line 1 and line 2 is actually 90 degrees. And once you recognize that, that will actually lead into exploring what makes line 1 to be related to line 2 mathematically. So looking at line 1, this is the equation, and for line 2 we recognize the equation as well. What we see is that the two slopes, there is a little flip in the factors. What we see is that we have a negative sign going from line 1 to line 2, and we see that the denominator becomes the numerator and the numerator becomes the denominator going from line 1 to line 2. So therefore we recognize that the slope is actually a negative reciprocal in order for we to have a specific lines that are perpendicular to each other. So if you are perpendicular to each other, it means that your slope must be the negative reciprocal of that particular other slope. Therefore we can actually conclude that those two lines actually make 90 degrees with each other, And if you want to remember, what you can do is multiply the slope of line 1 and multiply the slope of line 2, and you should get the answer to be always -1. And that is a big hint right there. If I give you two lines equations, if you multiply the slopes and those slopes are actually equal to -1, your conclusion right there is that they are actually perpendicular, not parallel. So we're going to look at examples on how to identify lines or to place lines as either perpendicular or parallel. So in here, this is a summary of it. Please try to remember in terms of symbolisms that when you see two stroke lines, this symbol represents parallel lines, while lines that actually cross each other like a T flipped upside down, that symbol represents a line that is perpendicular to the other line. So let's look at this question here. It says that we should state the parallel and perpendicular slope for each given slope. So M only represents slope. The M with the two lines tells me that this is actually dealing with parallel lines, and the M that has the T flipped upside down tells me that the two lines or that line is actually perpendicular to M. So let's look in here. For solution here, we recognize that the parallel line must be having a slope that is the same as M. So therefore, in this case, if we have 1/2, it means here that the slope for the parallel line will be half. Now, for the perpendicular line, we know that it has to be the negative reciprocal of M. Therefore, if M is 1/2, the perpendicular line will be -2/1, which is equal to -2. And if you do the same thing for the next rule, if it's -3 for M, the parallel line will be having a slope that is -3, and the perpendicular slope of that line will be the negative reciprocal, which in this case is going to be 1/3 positive. So that is it for that. And in here we have the parallel line to be -5/6. If we do the negative reciprocal of that to determine the perpendicular line, it means that we're going to have +6/5, because you're going from negative to positive. And finally here we see something quite interesting. We have a slope that is equal to 0, and when you recognize this, you actually see that if that is a parallel line, that is the same thing as 0/1, which means that your answer is equal to 0. Therefore, the slope tells me that that line is actually a horizontal slope, as we recognize that from our two videos previously. And if we do the negative reciprocal, the opposite of a horizontal line is a vertical line, which tells me that the slope won't be undefined because we have -1/0 as the negative reciprocal of 0. So in this case, we have an undefined slope, which is a vertical line right there. So that is some things to recognize in terms of examples on how to identify a perpendicular line from a specific slope and a parallel line with respect to that particular slope. So we're going to look at another example here, and in here we're given 2 points, P with that coordinates 2, -2, and Q with the coordinates -2 and 3. And in here we're going to be asked to determine the slope that is parallel to that particular line QP or PQ. And this line tells me that it is actually going to have a little bit of an influence also when you determine the slope that is perpendicular to that same line. So we have two questions to answer here. We have one that involves determining the parallel line, and the other question is determining the perpendicular line. So what is PQ with the bar on top of it? That tells me that if I have 2 points, the line between the 2 points is called the line segment. So once we have that taken care of, then we need to find what that line's slope is, which is between the 2 points P and Q. So in here, solution is to determine the slope of that particular line, which in this case we have to pick our Q and P and then assign our x1, y1 and x2, y2, and then we rewrite the algebraic expression for determining the slope of PQ. And in this case, once you put in your numbers, you should get your answer for the slope of PQ to be equal to -5/4. Therefore, in here, to determine the line that is parallel to that particular PQ, what we need to do is recognize that it is equal because they are actually having the same slope because they are parallel to each other. Therefore, the parallel line will be m with the parallel line sign is equal to the same number, which is -5/4. Therefore, visually, you should recognize that if this is the slope for the line PQ, the parallel line slope will be represented visually as that as well. So that is about it for A. And how about B? B is based on the slope of that particular QP or PQ line, which is -5/4. We know that for a line to be perpendicular to the other line, it has to be the negative reciprocal. Therefore, in this case, we need to remove the negative sign, flip the numerator and denominator, and we're going to get 4/5. Therefore, if we have the line for our PQ to be drawn like this, that means our perpendicular line, which is 4/5, will be represented as that right there. So this tells me that those two lines form 90 degrees with each other. So that is it in here for this particular question. And this particular next question is a little bit of a more comprehensive one, where in this case we're asked to determine the equation of a line that is perpendicular to this particular equation form, which is 10y is equal to 3x plus 60. Finally, I actually got the y's properly. I mixed them up in our previous video. I apologize in advance. So let's continue from there. So what we see here is that we need first to find a line that is, or equation that has a line that is perpendicular to that line and has the same x-intercept. So what you want to do for the solution is to highlight the things that are really important. So looking at the givens, we're given that particular equation of a specific line, which is expressed as that. What we need to do is to re-express this equation as y equals mx plus b. This is almost halfway done, which means that we will have to determine that particular y. So we're going to evaluate the y coefficient. In this case, what we're going to do is divide both sides by 10. In that case, we're going to have 3/10x divided by 60/10. Therefore, evaluating the constant, we're going to have this to be taken care of. So we're going to have our equation of the line, which is expressed as y equals mx plus b, where our m is 3/10 and our b to be equals to +6. Now what we see here is that the slope of this particular line is equal to 3/10, and once you recognize that, we need to find a line that is perpendicular to that particular slope, because you're thinking about slope. For perpendicular, we will have to do the negative reciprocal of that particular slope, 3/10. Therefore, we're going to have the formula or the factor to be -10/3 for that perpendicular line to that particular original line given in the question. So once we have that taken care of, our next goal is to find the x-intercept. So finding the x-intercept from the same particular equation given, we'll have to solve for that. And what we see is that we will have to express our equation when we make our y to be equal to 0. So when our y equals 0, we put that in the equation and we solve for x, and our x here will be equal to -12 20. So once we have that, after dividing both sides by 3, in here we've already determined our x-intercept. In this case is at -20, 0. Therefore, we'll find the two critical information required for we to create the new equation that is indeed perpendicular to the original equation. One is that we have the slope, which is the perpendicular one, negative reciprocal, which is -10/3, and the x-intercept, which in this case is -20, 0. So therefore, using the y equals mx plus b to determine the new equation that is perpendicular, we need to recognize that once we put in our m in that equation, which is -10/3, and x to be equal to -20 and our y to be equal to 0, we'll be able to figure out what our particular b is for that new equation. So therefore, in here, once we re-express that, we'll actually solve for b, and therefore we will have our b to be equal to -20 over 200 over 3. So this actually is pretty much the equation of the line. The equation of the line is expressing y equals mx plus b in terms of the new slope, which is -10/3, and finally here is using the b, which is -200/3. So this is the new equation that is indeed perpendicular to the original equation given in that particular expression right there. So that is it in here for this particular question, and finally is readdressing the original question that was given in the first 3 particular minutes of this video, which is here we should determine whether this is actually a right angle triangle given this specific vertices. So we have the vertices right there. What we need to do is first get your graph right there, and you locate the points. So point A, after write your solution, point A in here is 13, 3. So we locate that right there. And for our B is 3, 5, which we found right there. And for our C is you locate it right there, which is actually right there at the bottom. So once you locate those, what you can do is you draw lines to form a triangle, and that is the lines right there. And once you've done with that, then we need to find the slopes of each line that you see in that triangle. So once you have to do that, once you do that, then you'll be able to figure out which lines actually have negative reciprocal, because that is the key to highlighting what a triangle is. A right triangle, has a 90-degree between two lines. So if we find the negative reciprocal of one line to the other line, then that is a proof that that particular whole triangle is a right triangle. So let's find the slopes of each lines here. For the slopes, we need to recognize that using the graph or using this particular algebraic expression, we'll be able to figure out what the slopes of each lines is. So in here we know that for BA it is for that coordinates, and once you highlight your y to y1 and x to y1, we can actually figure out our slope of that particular line to be equal to -1/5, which is shown right there. And for line CB, we have the coordinates of that point, of those points. So if you express those as the algebraic expression, we will figure out our CB to be equal to 5. And finally, our last line, which is AC, we actually re-express that, and we figure out that our equation slope is actually equal to 15. So therefore, those are the two lines in here. That is the second line, which is m equals to 5, and other one is m, which is the slope to equal to 23/5. Now In this case, once we have all the slopes determined, we need to actually figure out that, or recognize at the back of your mind, that for a right triangle, 2 lines out of the 3 sides must actually be perpendicular, which means that they must form 90 degrees with each other. In this case, after drawing that, we notice that by observing our calculations, we see that we have our slope BA and slope CB to have a relationship that fits into the perpendicular criteria, which means that when I have 5 and I perform the negative reciprocal, that will give me -1/5. Therefore, this is actually a proof that, in conclusion, this triangle, it is a right triangle which forms 90 degrees between the 2 lines. So that's about it for this particular video. I hope you're able to understand and identify a parallel line from a perpendicular line, comparing the slopes of the 2 lines and applying those into real questions involving creating shapes, mainly dealing with a right triangle. You can do the same thing for a rectangle. If I give you 4 lines and I tell you to do this particular problem, you should be comfortable in doing this. And if you have any questions, please don't hesitate to contact me either by email or through Google Meet. All the same, stay smart and believe in yourselves.